So the square root of t is t to the 1/2 times this a plus b t. Okay, we have a lot of variables here, but the fact that it says it's f of t tells me t is the variable, a and b are going to act as constants here. Okay, so when I do the product rule, because I have things being multiplied, we do one derivative at a time. So do you guys want to do the derivative of the first one or the second one? Second one. Okay, so it's the first times derivative of the second. If a is a constant, what is its derivative? 0. Plus, what's the derivative of b, t?
T.
No, 0.
Oh, it's just B. It is just B.
Oh, because t is 1.
Shoot, dog.
So
Bro.
it's 0 plus b times the derivative of t, which is just 1. So that whole thing is just b. Does that make sense?
Plus
Oh, it makes tons of
Okay.
sense.
So
1/2.
the first times the derivative of the second plus derivative of the first. So the 1/2 comes down. T, subtract 1 from the power,
Negative 1/2.
times.
A plus bt. No, yeah.
So now if we simplify, we get b t to the 1/2 plus, if I distribute, 1/2 times a, I could write that as a over 2, t to the negative 1/2, plus 1/2 times b would be b over 2, t to the negative 1/2 times t, so you add exponents, negative 1/2 plus 1 is positive 1/2. Do we have like terms?
Yeah, we do. Oh, yeah, we do. Maybe.
Why would the
Yeah.
b be in the fraction, not the t that we multiplied? Like if we're
I mean,
multiplying both of
technically,
them.
you could put either one. I just, b is the coefficient here, so that's why I wrote it. These are both t to the 1/2, so you can add their exponents. So b, that would be the same as 2b over 2, right? Plus 1b over 2 would be 3b over 2, t to the 1/2. Let's say over 2, t to the negative 1/2. So, we can only do derivatives with one variable at a time. If you have multiple letters, the others are acting as constants in this case. Just hungry.
It's like there's 3 in there. What do you think?
Alright, let's try another one.
This one
I
looks
don't like
scary.
So, if f of x equals the square root of x, which we've said is x to the 1/2, times some function g of x, but I didn't tell you what g of x was. So let's think about if we did this derivative. Product rule says you do the first times the derivative of the second. So, the derivative of g. Now I don't know what g is, so I can't actually work it out, but I could say g prime. That means the derivative. Plus derivative of the first, derivative of x to the 1/2. 1/2. Times the second. Okay, so this is essentially, we didn't get a nice derivative because we don't know what g is, but we've simplified as much as we can. Now, I want to find f prime of 4. So I am saying we are going to plug in a 4 for all of these x's. So I have a 4 to the 1/2 times g prime of 4 plus 1/2 4 to the negative 1/2 times g of 4. Okay, 4 to the 1/2, what does that mean?
2.
It's the square root of 4, which is 2. What is g prime of 4?
3.
3.
3. I gave us that in the problem. Okay, plus 1/2. 4 to the negative 1/2. A negative exponent moves it to the bottom. So it's like 1 over the square root of 4. So that's 1/2 of 4, we were told is 2.
2. Carson knows.
So we get 6 plus 1/4 times 2 is 1/2, or 6.5.
Because 4 to the negative 1/2 is 1 over 4 is the 1/2 that's multiplying in the half x to the negative 1/2.
Oh, okay.
What this means is 1/2 times 1 over 4 to the 1/2.
It shouldn't Carson be reprimanded.
Huh?
Shouldn't Carson be reprimanded?
Alright, are we okay there? Let's go to example 9. I think that's where we ended.
So this is the multiplication one.
Find z prime of t equals dz dt. So I'm just saying do the derivative. I showed you a couple different notations. If z is equal to this. So what rule are we going to have to do?
Low d high minus high d low over low.
Okay, quotient rule. We're dividing. So
Low squared.
low, so that's the bottom. D high. What is the derivative of 1 minus t cubed?
Negative 3t squared.
Minus high. D low. What is the derivative of 1 plus t to the 4th?
4t to the 3rd.
Over low squared. Right. We do want to simplify. If we have to do a second derivative or something, we want our answer to be as simplified as possible. So we're going to work through this. So if I distribute my negative 3t squared, get me 3t squared minus 3t to the 6th. Minus the other one, I distribute the 4t cubed.
Is that, if we were to distribute that negative first, would it just go to the first parenthesis?
Yes. Distribute my negative. We do have like terms. 4t to the 6th and negative 3t to the 6th is t to the 6th. We have a minus 4t cubed. Minus 3t squared. Over the 1 plus t to the 4th squared.
Will we always have like terms?
Not always.
It's so ominous.
Not always. Whenever you get into differentials inside of a differential.
I don't. Good
Fine.
question.
You're probably gonna get to it.
Yeah.
Go ahead. What is it?
What if you have to do 3 things instead of just 2?
You do one derivative at a time. So you do like the derivative of the first one, the next 2 stay the same. Then do the derivative of the middle one, the first and last stay the same. Do the derivative of the last one, the other stay the
It's
same.
just like statistics.
We will get to those, just not
Oh,
today.
Is that dz over dt thing then just the formula for
Just
dividing?
another notation for derivative.
Just another
That's a
thing
lot
to
of
float around in your
implementations.
brain.
One where you
Why
multiply
can't we
on
just have
top
one?
and then divide?
Because I didn't write
Probably.
count.
That would be evil.
You think that's our next question?
Dude, example time. I just said that. No. What did I do? Oh no, it's
You
not.
can cough out loud.
That's not a point. It's not. How many words?
Sorry.
Sorry, sister. Okay.
Sorry,
So-
that's just
Equation of the tangent line. We need a point and a slope, right? It gave me the point. How do we find the slope of a tangent line?
Derivative.
Derivative. So, the derivative What am I going to have to do this?
Really high.
Oh,
Minus
man.
high.
What's your rule?
Yes, with the
Yeah.
high and low or low and
I mean, you could get it that way, but you could do the definition. Yeah, we're doing the derivative. So low, d high. What's the derivative of u to the x?
Yes.
Minus high, d low. What's the derivative of the bottom?
X. 2x, sorry.
Over low squared. So if we distribute, we just get u to the x plus x squared u to the x minus 2x u to the x. So no actual like terms here. A slope is an actual number, but we know that x is equal to 1 for the point that we need. So if we plug in 1, what is e to the first? E
sorry, this felt like a
plus
question.
1 squared times e to the first minus 2 times 1 times e to the first.
2e. Rather 2e.
Oh,
Sorry.
don't make me laugh.
Oh, I'm sorry.
Over 1 plus 1 squared, so 2 squared is 4. But on the top, it's 0.
So is it still line?
Well, yeah, what kind of line? Horizontal.
Oh, whoopsies, wrong one.
What's the equation of a horizontal line? Y equals a number, and the y value is 1/2 e. If you didn't catch that, you could do the whole y equals mx plus b, or y equals m times x plus b.
So e is our x, or is it just?
No, it's just a number,
Okay.
because a horizontal line is y equals a constant.
Oh, so
And you already given us y. You gotta admit, that was really.
E plus e is 2e. Alright.
You gotta admit, that was really funny.
Okay, so the last thing here is just a table of everything we know so far with derivatives. Derivative of a constant is 0. If we have x to a power, power comes down, subtract 1. Derivative of e to the x is still e to the x. Constants can just stay in front. If things are added, subtracted, multiplied, we can do add and subtracted, we just do individual ones. If they're multiplied, it's product rule, divided, disclosure rule. We'll be adding to this list, but this is what we know so far.
Oh, goody.
So, you have book problems and the rest of class to work on.